Let's jump right into this explainer and completely shatter a huge illusion. The idea that just writing beautiful notes means you're actually learning. We've all been there, right? You spend hours meticulously writing down every word, creating these gorgeous pages, and you feel incredibly productive. But what if, most of that time was literally wasted? Let's dive into the hard truth about how our brains actually absorb information. To do that, we're looking at insights from a learning coach who has trained an incredible 25,000 students over the past 13 years. We are going to fundamentally rethink how your brain retains data. These aren't just unproven theories, they're the exact methods the top 1% of learners use to master massive amounts of complex information in a fraction of the time.
So instead of throwing a fragmented list of tips at you, we've organized these secrets into 4 step-by-step pillars. We'll hit the note-taking illusion, move on to the architecture of memory, look at the modern learner's toolkit, and finally wrap up with building your memory lifecycle.
All right, let's kick things off with our first pillar, the note-taking illusion. It is time to take a hard look at some of our most comfortable, but honestly inefficient, note-taking habits.
Here's the thing. Writing notes is often just a physical activity. True learning, on the other hand, is a biological process that only happens when your brain is actively evaluating information. Think of it like a Venn diagram. In one circle, you have the time spent just moving your fingers across the page. In the other circle, actual learning. For a lot of us, the overlap there is tiny. If you're writing but your brain is essentially switched off on autopilot, you simply aren't learning. The goal is to make those two circles perfectly overlap. Less mindless transcribing, way more active processing.
And please ditch the highlighter, because highlighting only tests if you recognize a text, not if you can actually recall it for a test. When you drag that neon marker across a page, you're making a quick decision that something is important, sure, but you're completely bypassing the cognitive effort required to actually learn it. It's so easy to confuse recognition, looking at a page and going, oh yeah, I know that, with recall, which is your ability to pull that information completely from scratch during an exam. Copying diagrams or copy-pasting someone else's notes creates this really dangerous illusion of knowledge. It's literally like going to the gym, watching someone else lift weights, and assuming you're going to get stronger. Just because a perfectly detailed diagram is sitting there in your digital notebook absolutely does not mean it's sitting in your brain. To build that knowledge muscle, you have to do the heavy lifting. You've got to extract your own meaning, summarize, and connect the information yourself.
Okay, moving to pillar number 2, the architecture of memory. Because once we actually understand the machinery up in our heads, we can really start to hack it.
So your memory relies on networks, or schemas. And if new information doesn't fit into an existing schema, your brain will ruthlessly prune and forget that irrelevant data within minutes. This is literally a biological survival mechanism. Your brain doesn't want to waste energy holding on to floating, disconnected facts. So if you just read a linear list of bullet points without attaching them to a bigger picture, your brain basically hits the delete button almost immediately to save energy.
To put that into perspective, reading those linear bullet points takes massive effort, whereas processing nonlinear visual maps is up to 40,000 times faster for your brain. Seriously, 40,000! Think about reading a paragraph explaining that A leads to B when C and D combine. Reconstructing that logic in your head takes a lot of mental strain. But if you just draw A pointing to B with C and D feeding in, bam! Your brain processes that image almost instantly. Nonlinear notes lean right into your brain's biological bias for thinking in networks. So rather than just coloring facts, physically grouping related concepts together forces you to make active decisions, and that deeply anchors your spatial memory. Let's be real, we're pretty terrible at remembering specific colors anyway. The actual value of color coding is the decision-making it forces. But we can take this much further. If you physically map out 3 related concepts in the top right corner of your page, make the most important text massive, and draw thick arrows to show strong relationships, you are feeding your brain incredibly rich visual and spatial cues that it loves to hold on to.
Let's look at how this becomes a practical workflow. You can naturally transition to nonlinear notes by progressively shrinking your sentences down to mapped keywords. Don't try to overhaul your whole system overnight, okay? Start by simply cutting out the filler words. Then, maybe start drawing lines between your standard bullet points. Before you know it, you'll naturally start clustering those keywords into mini mind maps, and eventually you'll realize you don't even need linear notes at all.
That brings us to our third pillar, the modern learner's toolkit. Because sometimes the sheer volume of information coming at you just requires a totally different approach.
Instead of frantically transcribing everything, use AI to summarize your lecture audio into a baseline paragraph. It's a total game changer. Next, avoid those rigid, linear flowcharts. Why? Because if concept E relies on D, which relies on C, a single memory failure breaks the entire chain. And finally, just like an artist who periodically zooms out from a canvas to make sure an eye isn't on the wrong side of the head, you've got to step back frequently. Zoom out to check the big picture and ensure those tiny details you're studying actually fit into your broader schema.
Remember, your brain doesn't remember things like a robot, so hack it by drawing highly exaggerated memory aids. Imagine turning a boring cell diagram into angry caterpillars or swirling vortexes to emphasize easily forgotten details. If your textbook shows a perfectly drawn cell with tiny, realistic, microscopic bumps, you're going to forget those bumps. But if you draw those bumps as little houses on grass or angry caterpillars, you've just hacked your attention. You know they aren't actually caterpillars, but that bizarre, exaggerated image creates a super sticky memory cue that pulls the real factual detail right back into focus.
Also, invest in a digital, infinite canvas note-taking app like Apple Freeform. Otherwise, rearranging a connected thought on paper feels like demolishing a warehouse just to move one package. When you're studying, your understanding of how things connect is constantly evolving. On paper, realizing a massive conceptual web actually belongs on the other side of the page means erasing everything and starting over. That friction totally stops you from organizing your thoughts. An infinite canvas? You just lasso an entire network of ideas and drag the whole shebang wherever it needs to go, instantly.
Finally, let's wrap up with Pillar 4, building your memory life cycle. This is where the theory actually meets your daily schedule.
You absolutely must apply the 24-hour rule to combat the memory decay curve. Think about it. If you spend an hour learning a complex topic on Monday and then ignore it until the next Monday, your brain naturally prunes 50 to 70% of it. You're going to spend another full hour just getting back to baseline. But if you review it on Tuesday, when you've only forgotten maybe 10%, it takes literally 5 to 10 minutes to plug the gaps and lock that schema into long-term storage. Here's a huge one. Never organize your notes by 1-hour lecture blocks. That is exactly like building a house room by room without a blueprint. You should always consolidate by the overarching connected topic. A lecture is just an artificial time constraint, right? The subject matter doesn't actually care that your professor ran out of time at 11 a.m. If you isolate Lecture 1 from Lecture 3, you are completely missing the crucial connections between them. Bring all that information together into one massive, topic-based map. So your perfect memory life cycle really comes down to 3 simple steps. First, prime your brain with a quick 20-minute pre-study before the week even starts, just mapping out a rough skeleton of the topic. Second, during class, write down curious questions instead of isolated facts, using something like the Cornell note-taking style to force yourself to connect ideas later. And third, when you're reviewing your beautiful visual map, take any stray, weakly connected notes and turn them into flashcards. Because those rare, disconnected facts, that's exactly what flashcards are built for.
So think about your current system. Are you actually building a schema of knowledge, or are you just doing a bunch of busy work? The top 1% of learners aren't necessarily smarter, they're just relentlessly efficient. They protect their cognitive energy, they ditch the highlighters, and they actively force their brains to connect the dots visually. So I want to leave you with this question to really ponder before your next study session. If you have to demolish your notes to reorganize a single thought, are your notes working for your brain, or are you just working for your notes?